Ladies and gentlemen, good evening. It's okay. My name is Yuan Chang. I am from Yushu University, Taiwan. Today I am going to present my paper title is A Wearable Multimodal Mental Management System with an Improved Data Transmission Circuit. Okay, the outline will contain 3 sessions. First of all, I will make an introduction of my paper's background and idea for this improved system. The second, the improved system transmission system, I will make an introduction for the context. It includes spy filter, data compressor, and total alarm system. We call it FDA system. Then I will make a break conclusion for everyone to deliver what we will deliver to everyone today. Okay. Nowadays, to use the multimodal signal biosignal detect system to detect a personal body signal like EEG, HRV, and HEZ signal is very popular for now. The system normally implement this kind of function block. It will include EEG sensor, HEZ sensor, HRV sensor, and also use their analog to digital converter and the digital control interface implement in this kind of system. But we find this kind of system still lack of beta transmission system to filter the input noise and reduce the scope output data size. That's why we propose to add our proposed spy filter and also our data compressor unit. Furthermore, we add a fall-down detect alarm system, FDA, to improve the risk of detect this kind of health management system. We call it FDA. Normally, this kind of transmission data will go through mobile or cloud system to do further analysis or transmission. Further, our proposed spy filter and circuit diagram. As we know, the essential of noise spices normally introduce high frequency signal. Hence, low pass filter composed of delay buffer and consider to remove the unwanted high frequency spikes. We propose a circuit diagram like this. We implement the NSF and PSF into the spice filter. And the NSF means the negative spice filter. And the PSF means we use it to filter the positive spike. The circuit will implement as follows. And the function of this kind of our proposed spice filter, it can filter the positive noise spiker, as shown under the slides. Also the negative spike under input signal. So we can filter the unwanted high frequency spikes in the circuit. Okay. Also, you can set down the power. Set the power by passing noise spikes only turns on the put down mode of the output driver, while -1 turns on the put up mode. Thus, we need two separate filters to be inserted between the output driver and pre-driver. This page shows the function similarity of the proposed spy filter. Normally, you can find this condition of the noise hazard CMOS IC as power item. Normally, will happen on this kind of condition that device state of free flow or malfunction counters, or generate some abnormal high frequency with noise or trigger signal on chip. or lose the original data of memory, or unstable voltage level, output signal, or power surge. If we induce the spice to be filled under the scope of signal, a normal signal, we introduce a spice under signal. And by use of our proposed spice filter, you can see the simulator result. All the spice filter can be filled. The unwanted spice noise can be filled. And also we test at 3 different colors, to get the simulation data. Okay. We use the spice signal to generate the input EEG signal real case and check with spice filter result. Okay, we score a spike filter as a spike like this, which have the negative spike and the positive spike, as shows on the screen. And as you can see, within the ray circuit, the unwanted spike are induced in the normal signal, and then since it's an analog signal, so we need to use the 12B AD converter to convert it to be digital signal. Also, as you can see, the unwanted spike still exists under normal data transmission. So it existed. So by use our spike filter to filter the unwanted signal point, we can get the pure or noise-free signal, digital signal as we want. Then this page shows spice filter chip implement spec and performance. The average power reduction between 100 to 200 megahertz data rate is almost 28% simulated given couple period high frequency noise spikes. In mention, we almost can save almost 30% of power reduction. We use many current algorithm to simulate this kind of result. And the chip spec, the proposed spike filter output cell is implemented by TSMC 0.65 microamp 2P4M CMOS technology. Okay, showing a touch the spec. Also, we want to highlight is this kind of proposed spice filter system has been adopted and published by year 2005 TICEAS committee. About the data complex unit, we implement a low complexity joint coding method for MP4 LS hardware encoder. And this kind of this proposed method is based on the structure of entropy coding and the interrelationship with the cross correlation of the residual and compression ratio. It can operate with multi-channel biosignals. It uses the difference between two channels as follows. And to evaluate the performance of this kind of method, we define the compression ratio as uncompressed file size divides compressed file size by 100%. And if you see the right side, for the broad diagram for the MP4 LS encoder, the diagram A architecture of the hardware encoder is multi-channel structure, and the diagram B is showing a single LS encoding processor. Yeah. By this way, we can take advantage of this kind of encoder. It's very good to use in to compress the multiple channel data for transmission. To implement this kind of data compress and increases efficiency. The big structure, we will divide the data stream into many different frames, even many different channels. The codified format, this kind of format will include subframe handler, residual handler, and residual body itself. Okay. We simulate this kind of hardware by loosely compression module with FPGA platform board for real-time healthcare monitoring system. And we simulate the expected compression ratio result. For easy signal, the compression ratio we expect to 1.18 to 2 CR compression ratio. And for HEZ, HRV signal, we expect it to 2.5 to 3.3 compression ratio. The overall average compression ratio should be 2.24 to achieve a better compression ratio. Okay, furthermore, we add a fall-down detect and alarm system. To implement this FDA system, we select a low power and high integrated device, which is serial name is ADSL345, which can meet the demand of force detection and alarms. Further function diagram as following. Okay. We also need to connect a microcontroller to handle the data transmission. For the fall-down alarm system, judge flow and signal, the most important key point is when in which condition the fall-down alarm system will be triggered and the alarm. Okay, the key point is when the free fall interrupt signal happen and or the continuous free flow signal detect. The fall-down alarm status analysis, why happen the wavelength signal as the occasion 1, then the FDA will go to the alarm, and alarm will continue critical alarm again. Yeah. That's why the critical condition, we will trigger the alarm system to do the alarm action. Finally, I will make a brief conclusion to summarize my presentation. First of all, we use the simulate design contain of 2-channel EEZ sensor from N, 2-channel near infrared system, we call it NIRS from N, and a 12-bit analog to digital converter to generate the body signal source for EEZ, HEZ, and HRV signal. We add a spy filter to improvement data transmission system, which can remove positive and negative spy. Also save the signal transmission power around 28% on the input signal entry FPGA. We add an MPEG-4 LS system in FPGA for about 50 to 70% data compression ratio. On the output side to improve data transmission rate in wireless system. Finally, we add the fall-down alarm system, FDA, add in FPGA to reduce the risk of accident by enjoy or increase the air safety with our proposed system. Okay. That's all for my presentation today. Thank you for your attention. Yeah.
Any question?
Yeah. Is there any question?
To achieve a lot of things, you have added various equipment to the system, right?
Yeah.
Such as pipe filter, compression, and FDA.
Absolutely.
Yeah. So my concern is that your the proposed system
I think, okay, thank you for your question, sir. I think we have implement this different system into the FPGA to use simulation first. That's our first step. Yeah. The further step when we implement to evaluate the functionality is work. Then we will try to implement to maybe chip level implement. So we will reduce the area of all the integrated system inside. So we have a further plan for this proposal.
So just one chip or
Yeah, we will integrate all the function into one chip.
Just one chip.
Yeah.
So the complexity is not the issue.
Yeah, you're right. We will make it to be more positive, more user durable. Yeah, okay, more workable.
And my second question is, in the first stage,
Yeah.
you are interested in the noise of spikes, right?
Yes,
Spike.
yes.
So spike is one of the noises, right?
Yeah.
That is the major noise. So is there other noise also?
Thank you for the question. Actually, we already simulate the major kind of noise type. Normally, as we knowing, the high frequency noise is the most knowing frequency, most knowing noise to induce on our normal data transmission. So, as you can see in my slides, we already simulate the possibly condition may happen the spikes or the noise condition. So we already capture most of the condition we can do. But we also use the spike filter. Okay. Let me go over to spike filter. Okay. We already do simulate for this kind of condition. Yeah. Actually, this kind of the four condition already cover almost, I think, maybe 80 or 90% of the noise spike. Yeah. That's why we use this kind. We use this kind with our proposed spike filter. We try to filter we simulate maybe the abnormal spikes will induce under normal signal, and we try to remove the unwanted noise as our proposed size filter. Yeah.
So then what's the main cause of spikes? Why do you have spikes?
Spike means normally for the noise spikes, it means some high frequency, maybe white noise is some kind of spike. White noise is a kind of name. Maybe some we unwanted, maybe when you free flow to transition the level will also have overshoot spike like that. Or maybe some current surge in the power system will create a spike. All these noise system is the signal is the unwanted signal we don't want. We want to remove them. So with my proposal, with my proposed spike filter, we can do almost remove over 90% spikes of this kind of situation.
From your explanation, I suppose that the spikes is very frequently occurring noise, right?
Yeah, you're right.
Common noise.
Yeah. As measuring a closed function system, well, very easy to search some spice noise. Yeah.
Thank you.
Okay. Thank you.
Yeah, thank you.
Yeah. Thank you.
So then we have the second presenter.